Hi, as we are approaching Christmas time, we've been thinking about small gift for you. And as one clever person said, the biggest gift is the knowledge. So we would like to share with you our knowledge about our showcase, which you have seen in our previous video. For those who haven't seen the video, please have a look. There's a link below this video so you can have a look. And we'd like to share with you information about how everything is connected, how everything is working, because this is a question which we receive from many of you. You've been eager to see the real, let's say, devices and how everything is really put together. And we will start with a few slides which will show you the architecture, and then we will come back and have a look on physical item.
Here you can see the overall schema of the whole solution. At the bottom there's Intel NUC, which is a server running SUSE CaaS Platform. As you can see, the SUSE CaaS Platform is installed on 4 virtual machines, which is running on top of this physical box. So we do have one admin node, one master node, and 2 worker nodes. Those worker nodes, they are used for running of the containers. And then on the physical box there's one small application which we wrote, which we call dispatcher applications, and we will go in the details later on. And then this box is connected to the showcase, which you can see via USB hub. And then there are 6 Arduinos. The reason why there are 6 Arduinos is that each Arduino is controlling one line and also one lateral stripes and the sensors, which we will talk about again later on. So now let's move to the more details of how everything is communicating. On this slide you can see we have a worker node with several containers running on top of it. Then we do have this dispatcher application which is running on top of the physical box, and then we do have Arduinos. So the container is running code which you can see in the box. Basically it's a simple code where we are checking the state of the line, and then basically we are delivering a particular color, meaning that we send the train and we display the color of the container on the LED stripe of the diode. And we are regularly checking for the state. If the state is error, then we shut down the container, and then basically SUSE CaaS Platform is creating a new one. Next is the dispatcher application. So the dispatcher application is basically kind of a database of the state of different tracks. So it reading the status of particular tracks, and then it's saving them in a table. So in case a new container is spin, then the container asks this dispatcher applications if there's a free line, and the dispatcher applications goes through the table and see if there's a free line. Then it assign the line to the container, and then the container can deliver a particular color via dispatcher application. The communication between dispatcher applications and Arduinos are controlled by the track controller. So it's simple script which again is communicating with the Arduino, is checking the state of the train, whether the train is running or not running, and then it's basically sending this information to the dispatcher application. So in case there's an error, it will send the error via dispatcher application back to the container. Last piece and most complicated piece is the code which is running on top of Arduino. So the Arduino basically is checking the state of the train. It's using the wireless sensors, which we will show you later on during the physical demonstration. So basically, based on those information from the wireless sensors, we are able to see if the train is going from one station to another one, or if it was, for example, stopped or taken or whatever. Then after some time we will set there's an error on the line, and we communicate this error via dispatcher application to the container, so the container knows there's a problem and it terminates itself, and then the SUSE CaaS Platform basically spins a new one and it goes to the dispatcher application, and the dispatcher application basically see, okay, so that line was broken, so we will choose another line. So that was the reason why when we stopped the train, basically the line became to the error state, and via dispatcher applications we got this state to the container. We killed the container, or the container killed itself, to be honest, and then the SUSE CaaS Platform spent a new container, and the new container basically asked the dispatcher applications for free line, and the dispatcher application found a new line, and so it sent a new train. So that was the trick behind and how it was done in the previous video, that when we stopped the train, the new one was spin.
So we are back, and now we will have a look on the physical devices. And the first main part are the vital sensors. So we will open up those covers. And here you can see there are different sensors. Those sensors are for wireless distance. When we measure the train is arriving, so we stop the train and then we send the train back. So every time the train comes, it's detected and then it's sent back by the Arduino. Now we are moving to the back part of our showcase. As you can see, we have a fancy logo over here, just in case it's displayed in an open space, so it looks nice from the back side as well. But the magic is hidden behind this cover. I've already unscrewed 3 other bolts, so we have just one to put away. And what you can see here basically is what we've discussed are those 6 Arduinos. Each Arduino is connected to one train line, is controlling 2 sensors and 1 LED stripe of diode. It's connected via USB cable to the USB hub, which is hidden behind those wooden sticks. And then from the USB hub we have just one single cable which is connecting all those 6 Arduinos to our Intel NUC. So it's pretty much quite simple. There's USB connection between the Intel NUC and Arduino via the USB hub. And that's all. So I hope you enjoyed our video and learned a little bit about our showcase. Stay tuned for the future.